The world is moving. Every second, millions of engines fire, roads pulse, and cities breathe. But here's the truth, the way we move is changing forever. Electric transport is no longer a trend, it's a transformation shaping the next century. Today we explore the revolution powering global clean mobility. Electric vehicles, smart grids, autonomous transport, next-gen batteries, and AI-powered city systems. This is the future of movement, efficient, clean, connected. The shift to electric mobility isn't happening equally. Three major regions lead the race: the United States, the European Union, and China. In the United States, a nationwide push for electrification is underway, driven by federal incentives, the construction of fast charging corridors, and state-level EV mandates that are accelerating the transition. Across the Atlantic, the European Union is building its green mobility backbone with some of the world's strictest emissions laws, citywide bans on combustion cars, and a strategic focus on creating powerful charging density to eliminate range anxiety. But it is China that moves faster than anyone. Its EV adoption is the highest on Earth, with millions of electric cars, buses, and scooters moving through its cities daily. These three regions set the direction for the world, creating a competitive and collaborative landscape that is propelling the electric revolution forward at an unprecedented pace. So, why the urgent need to move to electric? The answer lies in the profound problems of our current system. The world's transport sector is a primary contributor to climate change, producing nearly 25% of global CO2 emissions. Beyond carbon, fossil fuel mobility generates a cocktail of toxic air pollution, nitrogen oxides, soot, and microparticles that choke our cities and harm public health. But perhaps the biggest issue is instability. Our reliance on fossil fuels ties our economies to volatile oil markets that fluctuate with conflict, geopolitics, and fragile supply chains. Our cities struggle with ever-worsening congestion, constant noise pollution, and a declining quality of life for their inhabitants. Electric mobility offers a comprehensive solution to all three of these critical challenges. It promises cleaner air for us to breathe, a shift to stable, domestically produced energy sources, and the creation of smarter, more efficient movement systems for our urban centers. The electric car isn't a new invention. In fact, the first EVs appeared in the 1800s, competing with steam and gasoline. But cheap, abundant oil took over the world until recent battery breakthroughs changed everything, reigniting the electric dream. Today's EV revolution is not built on a single innovation, but is powered by the convergence of four technological pillars. First, the continuous improvement of lithium-ion batteries. Second, the integration of AI management systems for optimization. Third, the synergy with renewable energy integration, allowing cars to run on sun and wind. And fourth, the rapid expansion of high-speed charging infrastructure. Let's break them down. Lithium-ion technology dominates today's EV market, and for good reason. It offers a powerful combination of strong energy density, a long cycle life, and crucially, falling prices that have made EVs more accessible than ever. But here's the twist. A new generation of battery technology is on the horizon, poised to redefine the limits of electric performance. Solid-state batteries are the holy grail. By replacing the liquid electrolytes found in current batteries with solid materials, they promise a monumental leap forward. We're talking about potentially twice the range from a single charge, dramatically faster charging times, a fundamentally safer chemistry that reduces fire risk, and a much longer operational lifespan. Meanwhile, chaming man na may ay China is pioneering the use of sodium-ion EV batteries, a technology that uses cheaper, more abundant materials, making it a stable and cost-effective solution ideal for mass-market vehicles. And for heavy transport and grid-scale storage, flow batteries present a unique solution using liquid tanks to scale capacity almost infinitely. Together, These diverse and evolving technologies are pushing the electric revolution forward, ensuring that the heart of every EV beats stronger, longer, and more efficiently than ever before. The shift to electric mobility isn't happening equally across the globe. While the hum of electric motors is growing louder everywhere, the revolution is being driven from three distinct epicenters. These are the powerhouses setting the pace, defining the technology, and shaping the policies that will dictate the future of how we move. Three major regions lead the race: the United States, the European Union, and China. Each is pursuing a unique strategy, a different blend of policy, innovation, and industrial might. Their collective actions are creating a powerful ripple effect, pulling the rest of the world into a new era of transportation. Understanding their individual journeys is key to understanding the global electric transition. Let's begin with the United States, a nation built on the freedom of the open road, now attempting to redefine that very concept for the 21st century. In the United States, the approach is a complex tapestry of federal ambition and state-level action. The US pushes nationwide electrification through a multi-pronged strategy. At the federal level, landmark legislation like the Inflation Reduction Act has supercharged the market, offering significant tax credits for new and used electric vehicles, making them more accessible to the average American family. This isn't just about putting more EVs on the road. It's a strategic industrial policy designed to onshore manufacturing and build a domestic supply chain for batteries and critical components. The goal is clear: reduce dependence on foreign oil and manufacturing and establish American leadership in the green economy. A cornerstone of this plan is the creation of robust, coast-to-coast fast-charging corridors. The vision is to eliminate range anxiety entirely, ensuring that an EV driver can travel from New York to Los Angeles as seamlessly as they could with a gasoline car. Federal funding is being deployed to build out a network of high-speed chargers every 50 miles along major highways, transforming the nation's arteries into conduits for clean energy. But the real dynamism in the US often comes from the states. Powerhouses like California have long been at the forefront, implementing aggressive state-level EV mandates that require an increasing percentage of new vehicle sales to be zero emission, culminating in a full ban on new gasoline car sales by 2035. These bold policies create a massive market, forcing automakers to innovate and scale up production with effects that cascade across the entire country. Other states are following suit, creating a patchwork of regulations that, while complex, collectively accelerate the national transition. Across the Atlantic, the European Union approaches the challenge with a philosophy of regulatory precision and collective commitment. The EU builds its green mobility backbone with a focus on systemic change, driven by some of the world's most stringent emissions laws. The Fit for 55 package, for example, sets a legally binding target to cut transport emissions drastically, effectively mandating a phase-out of new internal combustion engine cars by 2035. This top-down regulatory pressure forces the entire automotive industry, one of Europe's most vital sectors, to pivot towards electrification or face significant penalties. This isn't just a suggestion, it's a continent-wide industrial realignment. At the local level, this vision translates into tangible changes in the urban landscape. Hundreds of European cities have implemented low-emission zones, with many moving towards outright city bans on combustion cars in their historic centers. This reclaims urban spaces for people, reducing noise and air pollution and making cities like Amsterdam, Oslo, and Paris models for sustainable urban living. To support this, the EU is investing heavily in creating powerful charging density. The strategy isn't just about highways, it's about ensuring that charging is ubiquitous, From public chargers embedded in lampposts to vast charging hubs at shopping centers and workplaces, the goal is to make refueling an EV more convenient than finding a gas station. This dense, reliable network is the essential infrastructure that underpins the entire green transition, giving consumers the confidence to make the switch. But while the US incentivizes and Europe regulates, China simply outpaces everyone. In the global race for electric mobility, China moves faster than anyone. Its strategy is one of unparalleled scale, speed, and vertical integration, orchestrated through decisive government policy and fierce market competition. For over a decade, the Chinese government has nurtured its domestic EV industry with subsidies, research grants, and infrastructure mandates, viewing electric mobility not just as an environmental solution but as a critical strategic industry for the 21st century. The results are staggering. Today, its EV adoption is the highest on Earth. More electric vehicles are sold in China than in the rest of the world combined. This isn't a niche market, it's the mainstream. Walking through cities like Shanghai or Shenzhen, the electric revolution is not a future concept, it's the present reality. With millions of electric cars, buses, and scooters moving daily, the entire public transport system in many Tier 1 cities has been electrified, drastically cutting urban air pollution. China also leads in infrastructure innovation. While the West focuses on fast charging, China has pioneered and scaled battery swapping technology, allowing drivers to get a fresh battery in minutes. This model, combined with a vast and digitally integrated charging network, has effectively solved the range and recharge time anxiety for millions of users. From domestic giants like BYD, which manufactures its own batteries, chips, and vehicles, to innovators like NIO and XPeng, the Chinese market is a hyper-competitive ecosystem that is now beginning to export its technology and vehicles globally, challenging the dominance of legacy automakers. These three regions, the United States with its market-driven, incentive-based push, the European Union with its regulatory systemic approach, and China with its state-driven industrial-scale execution, are not operating in isolation. They are locked in a dynamic of competition and collaboration, each learning from the other's successes and failures. The technologies developed in a lab in California, the regulations passed in Brussels, and the manufacturing processes perfected in Shenzhen do not stay within their borders. They create global standards, drive down costs for everyone, and build international supply chains. Together, these three regions set the direction for the world, creating a powerful gravitational pull that is accelerating the global transition to electric mobility far faster than anyone could have imagined just a decade ago. Their combined momentum is creating the blueprint for a cleaner, more efficient, and more connected transportation future for all of humanity. Why move to electric? The world's transport sector produces nearly 25% of global CO2 emissions. Fossil fuel mobility also generates toxic air pollution, nitrogen oxides, soot, and microparticles. But the biggest issue is instability. Oil markets fluctuate with conflict, geopolitics, and supply chains. Cities struggle with congestion, noise, and declining quality of life. The electric car isn't new. The first EVs appeared in the 1800s, but oil took over the world until battery breakthroughs changed everything. Today's EV revolution is powered by four pillars. 4 rapid charging infrastructure. Let's break them down. If electric vehicles are the body of our transport future, then batteries are its beating heart. The entire revolution hinges on our ability to store and deploy electrical energy efficiently, safely, and affordably. Industry, and for good reason. They offer a powerful combination of high energy density, meaning they can store a lot of energy in a relatively small and light package, and a long cycle life, allowing them to be charged and discharged thousands of times before significant degradation. This is the technology that took EVs from niche curiosities to mainstream contenders. The journey of lithium-ion has been one of relentless innovation. Scientists and engineers have continuously refined the chemistry of the cathode, anode, and electrolyte, squeezing out more performance year after year. Cathode is the single biggest factor behind the explosive growth of the EV market. Lithium-ion technology dominates today's EV market. It offers strong energy density, long cycle life, and falling prices. But as powerful as it is, the era of lithium-ion's total dominance is approaching a pivotal moment. The demands of the future for longer range, faster charging, and absolute safety are pushing the limits of what liquid electrolytes can offer. But here's the twist. A new generation is coming, a technology that promises to redefine the performance boundaries of electric transport. Enter the solid-state battery. For decades, it has been the holy grail of energy storage, and now it is moving from the laboratory to the production line. Solid-state batteries represent a fundamental paradigm shift. They replace the flammable liquid or polymer gel electrolyte found in conventional lithium-ion batteries with a solid, stable material, often a ceramic, glass, or solid polymer. This single change unlocks a cascade of transformative benefits. First, safety. By eliminating the volatile liquid electrolyte, the risk of thermal runaway, the chemical chain reaction that can lead to battery fires, is virtually eliminated. This makes solid-state batteries inherently safer, allowing for more aggressive charging and discharging without the complex cooling and management systems required today. Second, energy density. The solid electrolyte acts as a perfect separator, enabling the use of a pure lithium metal anode. This is a game changer. A lithium metal anode is incredibly energy dense, a time comparable to filling a tank with gasoline. Safer chemistry. As we've seen, the solid structure is non-flammable and more resilient to damage on longer lifespan. Solid-state designs are also more resistant to the formation of dendrites, tiny needle-like structures that can grow inside liquid-based batteries. that is over 1,000 times more abundant in the Earth's crust and can be extracted from common salt. This abundance is its superpower. Sodium-ion batteries completely sidestep the geopolitical and environmental concerns associated with lithium and cobalt mining. They are significantly cheaper to produce, making them the perfect solution for mass-market, entry-level electric vehicles. China leads in sodium-ion EV batteries, cheaper, stable, and ideal for mass-market vehicles. Companies like KTL and BYD are already Sodium-ion isn't just an alternative, it's a breakthrough. But what about the giants of transport, the heavy-duty trucks, the cargo ships, the trains? Their energy needs are on a completely different scale, requiring a different kind of solution. This is the domain of the flow battery. Unlike conventional batteries that store energy within their solid electrodes, flow batteries store energy in external tanks of liquid electrolyte. The two liquids, an anolyte and a catholyte, are pumped through a central stack of electrochemical cells where the energy exchange happens. This unique design decouples power from capacity. To get more power, you simply make the cell stack bigger. To get tanks to scale capacity. Imagine an electric semi-truck pulling into a station. Instead of waiting hours to recharge, it could simply swap its depleted electrolyte tanks for fully charged ones in minutes, a process known as refueling. Their near-infinite cycle life and lack of degradation also make them perfect for stationary grid storage, where they can absorb excess renewable energy from solar and wind farms and release it during peak demand, stabilizing the entire power grid that our EVs depend on. From the high-density power of lithium-ion and the game-changing promise of solid-state to the affordable accessibility of sodium-ion and the industrial scale of flow batteries, there is no single magic bullet. Instead, a rich ecosystem of battery technologies is emerging, each tailored to a specific need. This diverse portfolio is what makes the electric future not just possible, but inevitable. Together, these technologies push the electric revolution forward, creating a cleaner, more resilient, and more dynamic world in motion. A transport revolution is nothing without charging. The world builds at record speed. Fast chargers on highways, ultra chargers in cities, wireless charging roads, solar-powered stations, battery swap hubs in China. But the real advancement isn't hardware, it's intelligence. AI predicts when and where EVs need power. Smart grids distribute energy efficiently. Vehicle-to-grid systems let cars send electricity back to homes and power networks. Electric transport is more than cleaner engines. It's an intelligent ecosystem. AI optimizes charging schedules, fleet movement, route planning, battery life, energy balancing, autonomous driving. In future cities, electric buses and self-driving shuttles operate with millisecond accuracy. AI controls intersections and traffic waves, reducing congestion and emissions. The revolution is not just about cars. Electric mobility includes e-bikes, e-scooters, electric buses, electric freight trucks, cargo drones, autonomous taxis, electric ferries, light rail systems, hyperloop concepts. This diversity makes cities cleaner, quieter, and more accessible. Electric transport reshapes global economies. Countries investing early gain, new industries, skilled jobs, cleaner cities, stronger supply chains, reduced oil dependence, increased resilience. For consumers, EVs promise lower running costs, fewer repairs, and long-term savings. Norway, world leader in EV adoption, over 80% of new cars are electric. China, largest EV market, mass adoption powered by BYD, SIEC, XPeng, and Tesla. United States, massive growth with the IRA driving EV tax incentives. UAE, solar-powered charging infrastructure in desert environments. Australia, rapid charging networks grow across highways, suburbs, and EV fleets. The next decade brings stunning breakthroughs: solar-integrated vehicles, ultra-fast 2-minute charging, battery materials with zero cobalt, fully autonomous transport lanes, citywide electric freight, AI-managed mobility grids, hydrogen-electric hybrid systems. The world is accelerating toward clean mobility. Electric transport isn't just a technology shift. It's a commitment to healthier cities, stable energy, and a sustainable future. Would your city embrace this electric transport revolution?